Hi, today I want to talk about the operators in free Pascal. Uh, when you want to do different operations with variables or with constants, then you will need operators for this. The first thing where I would like to start is the type conversion between variables or constant types. So for this I was defining here some variables, some of them integer values or byte values or character variables, and I just want to show how you can convert between these variables from one type to another type. So if you have an integer variable and you want to convert it into a byte variable, then you can use the byte function, and then as a parameter you use the integer value, and you can convert the integer into a byte. From this byte value, or even from the integer value, you can generate a character. Now in this code I'm also generating from this byte value a character value, and just to show the results, I'm always writing out these converted values. Actually, if you would like to have operations with different types, here I am showing also this, that I'm converting the integer value into a double value and multiplying it with an integer number. In this case, of course, the result will be a double value, because the double value is basically containing more precision than, of course, the integer value. So to represent this result, even if the I value itself is an integer, the compiler will consider it as a double due to this conversion in the operation. So you will see here, when it is written out, that the R value will be a double value in a form of a real value format. And also you can see that if I would just multiply the integer number with a 2, then which is also an integer value in here in this operation, and then the result will remain as an integer value, so there will not be decimals behind the number at all. The next one is the arithmetic operators, and here the operators can be a plus, a minus, multiplication, division, and then also integer division and remainder, let's say division. So to show these, I was just having here the plus operation, so an addition, and the division and multiplication I was not showing in this code. I'm showing here the division and also the integer division and remainder, let's say operation. And here I put in into remark some lines, just to show that how you can use this in the practice. So you will see also this one, how this can be let's say converted, or how this can be used for other variables as well, not just for the printing or writing them out to the console. Then the next operators are bitwise operators. So these are basically using the values used for the operation based on their binary format, and making basically this binary operations with the numbers we add to these operators. So here the most interesting will be, of course, when we are using simple numbers here, and then we are using the or and operation. Next one is a Boolean operation or Boolean operators, where the check or the Boolean values, basically these are also can be considered as binary values. However, just the result will be a true or false. So depending on if the result is a 0 or if it is a 1, then this will be true or false. Of course, if we have such kind of Boolean values where not just the 1 but also the higher numbers mean true, then of course the result will be considered like this. Here what is important to mention that if you use these binary operators in an if statement, then the if statement is trying to evaluate the operation from left to right, and if these finally let's say lead to a result that even if you would consider to or even if you would like to go to the right to evaluate further the operation, but this would not change at all the result of this operation or this Boolean check, then the if statement is not going further. So here I was defining a function, this getTrue function, which is not doing anything else, just returning a true result. But you will see that if this or because here the first check is already a true, and the true or true would be true again, then the second let's say function here inside the if statement will not trigger at all. So you need to consider this when you are making an application, that whenever you get to a result which gives let's say the evaluation unnecessary for the right from that point, then those elements will not be checked at all by the system. Next one is the string operator. So there is only one operator for strings, which is a plus. So basically you can add together strings, either these are string variables or string constants, then you can add them together, and then you will have one consecutive string at the end. Dynamic array operators, again we just have a plus. So these are basically making a union of the arrays. So if you have elements in one array and elements in another array, then after adding these together, the new array will contain all the elements. So here what is important to mention is that this can be used on static arrays, so where you define exactly the size of the array right from the beginning. So you can only define here dynamic arrays, and then you can use this operation on them. Next one are the set operators, where the plus is the union. So basically this is adding together two sets. The next one is the difference, which is only giving those elements which are different to the second, or which are different in the two sets. The next one is the intersection, which is giving the same elements. The next one is the symmetrical difference, so where you basically get those elements which are not the same in the two items. So this is the opposite of the intersection. Next one is the contain, and the other or the next after that is the superset of the right side set. Include and exclude is adding or removing one element into the set, so you can use these functions to add only one element to the set itself. And then we have the in operator, which is telling that if an element is part of the set or not. The last operators in free Pascal is the relational operators, what you can use in typically if statements or also in cycles to compare two values to each other. And the result of these relational operators are typically the bool results. So if the elements are equal, or the elements are not equal, or the elements are bigger or lower, or lower and equal, and so on. So these relations are checked by the system, and then you will get the result if it is true or false. So let's see, when we are running this small code here to show the result, then we get this result in the console, and let's go through of it. So what we see here. So when we use the I value, I'm just writing out that this is an integer value. Then this integer value is converted into a byte value, and the byte is converted into a character value. And if I'm checking the or writing out the character itself, then I get the A character, which is which has the bytecode of 65. And if I convert the constant A letter back into an integer value, then I get back the 65. So basically it's taking the code of this letter and convert it into an integer value. The next one was the multiplication, where I was converting the integer value into a double value. And as you can see, when you convert the value and multiply it by 2, then you get 130 in a scientific number format. If I'm multiplying the I with a 2 just without any conversion, then of course I get an integer value here, which is 130. So now going forward into the arithmetic operators, the first result is the I plus B. So here the I was 65, the B was a byte value, also 65, because the I was converted earlier, so this gives again 130. The next, and actually because the byte value was also a kind of integer value, the result, of course, again an integer number. So now we get to the division and the integer division and the remainder division. So here when I divide the 65 by 2, then I get a double number again, because the result will be will not be an integer value, so we will have a fractional value here. And actually this I'm showing here with let's say this formatting characters as well, so only 2 digits are written out here. So when we make the integer division and divide the I with a 2, the result is 32. So only the integer part of the of the number we get, or the result we get back, and basically the remainder is lost. So we just get an integer division here. To know if this division was let's say a perfect division, or we had a remainder, we can use the mod operator. So I mod 2 will give a 1, because if we divide the 65 by 2, then we can divide as an integer the 64, and the remainder is 1. So here you get 1 when you use this operator. The next one is the bitwise operators, and here you can see that I was writing out the not 1, which gives a -2. Not 0 gives a -1, and not -1 gives a 0. So as you can see, as the number what we are using here is considered to be an assigned integer value, when we use the not operator, is basically converting bitwise the number to let's say to the opposite number. So all the zeros will become 1, and all the ones become 0, and then basically we are mirroring the number to the 0. So actually you will get the opposite side of the number. So of course, because we have let's say a 2-byte value here, you can get let's say a shifted side on the plus and the minus side with this operation. So for the -1, that's why you get 0 and not +1. The next operator here is the let's say the shifting to the right or shifting to the left. So here I was using here shift to the right, and if we shift the 16 to the right, then by 2, then we get a 4. So actually this means that the byte, the 1 byte which you have at the 16 position moved by 2, that means you go down to the 4 and get the result as a 4. If you are shifting to the left, and you can use the SHR or SHL for this operation, but you can also use this these characters as well here to do the same. So actually, if I would use here the higher characters, then I would get the same result just as here. So now we have here the OR and the AND operation. I was also showing this binary-wise. What does it mean? So basically, if you you want to have 1 or 2, this will result in 3, and the reason is because the 1 is having the first bit 1, and the 2 having the second bit 1, and if you consider step by step at each position if it is a 0 or if it is a 1, and if there is a 1, so either it's a 1 or the other is a 1, then this will give the result as 3, because basically the result is 1 and 1 in both locations. When we are talking about the AND operation, so both bits should be 1, and because here either the first bit is 1 or the second bit is 1, when we make the AND operation, there is no matching ones at each location, so the result will be 0. To show this again, when we have matching bits in the number, so the 3 and 2 will result into 2, because at the second position we have 1 in each number, and the first position we only have 1 in case of the 3, so the result will be 2 based on this operation. So the next one is the Boolean operators, where I was just talking about the true and the get true function, and as you can see, because here the result is of course always give the true. This line is given, but to show the function, the get true function, I was having here a break for the operation. So if we would reach this line when I was running the application, the execution would be stopping here. But because this operation So this operation here, or this let's say Boolean check, stopped at this true, and the application was not evaluating further to the right, because the if statement could give always a true here. The get true function was never called. But if I would change this to false, and rerun the application. So as you can see that when I'm running the application again, using the checking at first the false value, and then checking the get true function result, then of course the application was running the function as well, because the false was still not let's say giving or finalizing the result for this OR statement. If I would have here a true and true or get true, then of course both needs to be run, because the first one is not necessarily result in a true value without the function itself. So now running it again, of course the application goes into the function to get the result, and only when it is evaluated, then it gives the result to here. So let's go to the next one. So the string operators, of course you can see that I added together 3 individual string constants, and then I'm writing out only the variable, and of course I have here the odd string together as one string. Dynamic operators or dynamic array operators. So here when I'm adding together the two arrays, then and writing out the fifth, actually the sixth element, because the dynamic arrays are starting from 0, so the first element is let's say considered with the 0 index. So the fifth element will be the 6, and this is exactly what we get here. and if I'm checking the length and the high value or high index of the dynamic array, then I get back the 6 and the 5. So now we got to the set operators, the intersection, and so on. So if we are going through, you can see the results here. So adding together the two individual sets here and printing them out, then we get the, let's say, the union of it. Then if we take out from the Monday, Tuesday, Wednesday, the Wednesday, then of course we get the Monday, Tuesday. So the next one here is basically the same. The only difference is of course here that we not just let's say remove the Wednesday, but also if there would be a Tuesday, then we would remove it as well. So then the next one is the intersection. So basically here we only have the Wednesday, which is the same in both sets. The next one is giving just the difference between the two sets. So because the Wednesday is the only let's say only element which is contained by both sets, this is the only thing which is removed. So you can see here that the Monday, Tuesday, Thursday and Friday is in. Then the next one is showing that the work week is actually from Monday till Friday, and if we check that if the Monday, Tuesday is within the work week, then it says that you must work on Monday and Tuesday. So if the weekend days are a superset of this one, so the Sunday, then you can rest on the Sunday, and this is exactly what we get here. So then I also added here the include function. So here the last element we got was this one. So the Monday, Tuesday, Thursday, and Friday was inside the set in the W variable, and we are adding here the Saturday, writing it out. Of course, the Saturday appears here, and then with the next one I remove the Saturday, and then we get back again the previous variable with the Monday, Tuesday, Thursday, Friday. And then here just to show that if the Sunday is in the work week, so actually I'm just comparing it with the W variable. So this one was of course this Monday, Tuesday, Thursday and Friday, and because Sunday is not in, we get a false here. And if I'm checking if the Friday is in the work week, of course it will be in. So the result is for this Friday in W is actually gives a true. That's all for today, and if you like this tutorial, don't forget to subscribe. And with this I wish you happy coding. See you next time. Goodbye.